Hello and welcome back to the Kids Heaven Public School online classes. Now, as we started with our computer studies for grade 11, this is another important part of the conversion process. Now, we have seen conversion using whole numbers, that is 1, 2, 3, 4 and all. Now, we will see how to convert if we have a fractional part in the whole number along with it. Okay? For example, if you are given a number 0.35 in base 10 and we have to convert this to another number system. How do we do that? Because here it's a 0 and we have a fractional part. So how will this be converted? Now let's quickly look at this. Once you go through this, I'm sure you will understand it. Okay, so decimal number with fractional part to binary. Okay, we will begin with the fractional part. Let's now understand the rules. What are the rules for converting these fractional parts to any other type of number system? Now rule number 1. Whenever we begin a multiplication of the fractional part, keep in mind the number we are converting it to. Okay? The number system to which we want to make the conversion, we will use the base of that number to multiply the fractional part. Okay? For example, get this. This is a number in base 10. 0.25 base 10. We are to convert this to a number in binary which has a base of 2. Therefore, during the calculations, the multiplication will be done using the base of 2. Not any other number but 2, because we are converting to a binary number. Let's begin this. You will understand it better. The first thing we do, we write the number. The second thing we do, we multiply it by the base of 2, because we are converting to binary. Before we write the answer, let me tell you an interesting thing. Draw an arrow downwards. Up here, write integer part. Okay? Before you write your answer, draw an arrow pointing downwards. Up here, write integer part. Now, I'm sure you all know, in a decimal number that has a fraction, 0 is the integer part, 25 is the fractional part. So, we are going to write here the integer parts of each of the answer we receive. Now, another important thing to observe, understand and always remember during this calculation. When we begin multiplying by this base of 2, we will stop only when the integer part turns 0. Rule number 1, it turns 0. Rule number 2, if the integer part does not turn to 0 with subsequent multiplications, how do we stop? We stop when the integer part begins repeating itself. If we have an integer part of 200, after 5 multiplications, a 0 doesn't come, but instead 200 comes, we can stop the multiplication. Now let's look at this. 0.25 multiplied by 2, which is equals to 0.50, isn't it? Now, we have an integer part here of 0, which we shall note down here. We don't have a 0 here, so we continue with the multiplication. Note down this here, 0.50 multiplied by 2. What would be the answer to this? Yes, 1.00. The integer part here is now 1 and the fractional part is 0. So we can stop the multiplication here. Okay? Therefore, this number in base 10, 0.25 in a base of 10, a fractional number is converted to binary to give us a 0, 1. 0, 1, base of 2. fractional part. Therefore, this 0, 1 is going to be written as a fractional part. Okay? Now this is right. We are calculating for the fractional part, so it will be written with a 0 point. Okay? Now I hope that's clear. Now let's convert a larger number to a binary from a decimal. We are going to calculate using the fractional part. So first of all, 0.675 multiplied by 2. Before we write the answer, remember, draw your arrow right here, integer part. Okay? So we have 0.675 multiplied by 2. What is going to be the answer to this? 1.350. 1.350. Our integer part here is a 1. Note it down here. Next, when we are going to multiply now, we are not going to pick this 1. We are going to write 0.350 multiplied by 2, which is equals to 0.700. Isn't it? Now the integer part here is a 0. Next we pick 0.7700 multiplied by a 2, which is equals to 1.400. The fractional part is 1. Next, 0.400 multiplied by 2. What is this going to be? 0.800. We have another integer part as 0. Then we pick 0.800 multiplied by 2, which is equals to 1.600. The integer part here is a 1. Then we have 0.600 multiplied by a 2, which is equals to 1.200. The integer part here is a 1. Now have you observed? We are continuously multiplying. We have not yet stopped. Why? Because up till now we have not achieved a 0 in the fractional part, and neither has any of the number been repeated. Okay? So we will still continue with this multiplication. The next one we have is 200. Now let's multiply this. 0.200 multiplied by a 2, which is equals to 0.400 with an integer part of 0. Let's write that here. Now look here, we have a 400 here and we have a 400 here. Observe, the fractional part is now repeated. Therefore, we can stop our multiplication. A 0 did not appear here. The way a 0 appeared here and we stopped. Here, our fractional part has repeated itself. Therefore, we will stop the multiplication. Now what do? We note down this number. Okay? The integers that we have deduced, we note them down. Now this is going to be equals to, we read it from the top to the bottom. Don't forget, it is a fractional part. So we are first going to put a 0.1010 110, and this is our new binary number. Okay? So when we are converting a fractional part of a decimal number to a binary number system, we multiply by the base of 2. We keep multiplying till the fractional part becomes a 0. We stop. Else, till the fractional part repeats itself, then we can stop. And the integers that we have noted down will now result as the answer in a fractional form. Okay? So this was about decimal to binary and a larger number also decimal to binary. Now let's see if we have a decimal to an octal number. How do we convert that? Okay? Now, we have a number 0.675. Now what are we going to multiply this with? Give it a thought. we are converting from a decimal fractional part to an octal number. What are we going to multiply with? That's okay? With an 8, because we are converting to octal, and octal is in the base of 8. So again, put down your arrow and note down the integer parts here. Okay? So in the first one, when we multiply 0.675 by an 8, what do we get? 5.400. Okay? That's the first answer we get. So the integer part here is a 5. Next we keep on multiplication. 0.400 multiplied by 8. What is that going to be? 3.200. The integer part here is a 3. See, we have not yet got a 0 and nothing is repeated. So we continue with the multiplication. 0.200 multiplied by 8. What is this going to be? 1.600. We have a fractional part of, we have a decimal. This number here, our integer, we note it down here. Now we have 600, nothing is repeated, there is no 0. We keep on with multiplication. Now this will result in this. Okay? Is there any repetition? No. There is still no repetition here. And our integer part here is 4. Now let's do it once more. 800 multiplied by 8, which is equals to 6.400. And here we have a repetition. Can you see that? We have a 400 here and we have a 400 here. The fractional part has been repeated, so we can now stop the multiplication. Note down the integer value here. Okay? Once we have noted it down, we can quickly put on the answer here. We can reduce and write the answer, which is a 5, 3, 1, 4, 6 in base 8. Okay? This is now our new octal number. But is that how we are going to give the answer? I wish you could object to that. I write it and then I have erased it. Do you know why I did that? So that you will keep in mind that we are calculating fractional part. So it must begin with a 0 point. Okay? It has to begin with a 0 point. So 5, 3, 1, 4, 6, base 8. That is going to be the octal conversion of this fractional number of a decimal. Okay? Always remember you have to put the 0 point first. If you give the answer directly, that's a whole number, which is wrong. Okay? So now let's look at the last part, converting this decimal number with a fractional part to a hexadecimal number. We are going to apply the same methodology applied by the base here, which is a 16. So let's begin. 0.675, okay, multiplied by 16, which is equals to, let us quickly note down the integer parts. So 0.675 multiplied by a 16, which is 10.800. Now we have a fractional part here of 800 and an integer part of 10. We are noting down our 10. Now pick the fractional part. 0.800 multiplied by 16. What is that going to result into? 12.800. We can see in the second multiplication the fractional part has been repeated. Therefore, we can now stop the multiplication. Pick what your integer part here is. Okay? Now we have received an answer of 10 and 12. But in hexadecimal form, 10 is an A and 12 is a C. So instead of writing these numerical values, what we do, we write 0.AC base 16. This will be our answer. Remember, a 0 point because we are calculating the fractional part. and we are using A and C because according to our conversions, 10 is an A, 12 is a C. So this was the conversion of the fractional part of a decimal number. We have converted to binary number system, to the octal number system, and to the hexadecimal number system. I hope this is really clear. Still, if you do have any problem, try and always get back to us. Okay? Thank you.